So let's start lecture 2, summaries of data. So in lecture 1, we talked about the introduction of biostatistics. So in the second chapter, we'll continue the concept of descriptive statistics. So to recap, what do we do in descriptive statistics? Is the process of collection, summarization, analysis, and presentation. So we'll see each of them one by one as we go along in the lecture. So how it is done and how to continue with the analysis of any data. So in this lecture, we'll talk about descriptive measures. What is the measure that we use? And we'll talk about two types of measures, measures of central tendency and measures of dispersion. I will discuss more as we go along the chapter. And next, we'll talk about group data and finally, graphical methods. So the descriptive measures are basically a summarization method. So all of these are used for summarization. And group data frequency distribution is and group graphic methods are generally used for presentation. Now, what is descriptive biostatistics? So the best way to work with the data is generally to summarize and organize them. So the measurements that we have not organized or summarized or otherwise manipulated are called raw data. So whenever you hear something raw data, it means that it's not organized, it's not summarized, and it's not manipulated. So this is called as raw data. So what are descriptive measures then? So whenever you say the term descriptive measure, remember that the ability to summarize the data by means of a single number is called as a descriptive measure. So think of this as a measure of summarization. We are basically summarizing the data using the principle that we just talked about. So what do we do in summarization of this data is that we take the descriptive measures is basically generally computed from the data of a sample or the data of a population. So a descriptive measure computed from the data of the sample is called as statistic, and a descriptive measure computed from the data of a population is called as a parameter. So this is important. Why? So we talked about sample and population. So a sample is the part of a population. So when we analyze, we are not analyzing the entire population, we are analyzing the sample. So that's why whatever the descriptive measure that we use, that we get from a sample, is called as a statistic. While data that you get from a population, so the descriptive measure from a population is called as a parameter. So what are the types of descriptive measures? There are several types of descriptive measures that can be computed from a set of data. So but we only use two important types. One of them is the measures of central tendency, and the other is the measures of dispersion. So what are these? And let's look at each of them. So let's start with measures of central tendency. The name itself says that the measure is looking towards the center. So the measures of central tendency, the other name for it is the measure of location. So is also another is a form of measure that's commonly used to summarize the data and define the center of that data or the middle of that data, middle of the sample. So the measures of central tendency basically convey information regarding the average value of a given set of values. So again, average, so focus on this word average. That does not mean every time average is the same. So there are three different most commonly used measures of central tendency. So one is mean, number two median, and number three mode. So let's discuss each and every one of them. Let's start with the mean. There are three types of means. There's arithmetic mean, geometric mean, and harmonic mean. But the most familiar measure of central tendency is the arithmetic mean. So why is it the arithmetic mean needed? Notice that, so since the geometric and the harmonic means are generally things that we do not use in this lecture, but the reason mainly is because these are more commonly used in calculus and algebra, and they are not much of a, much to use in biostatistics. The one that we focus on here is the arithmetic mean. So simply referred to as the mean. So whenever we talk about this mean, whenever we say the word mean, it means we are talking about the arithmetic mean. So remember that concept, that when we talk about mean, we are focusing on the arithmetic mean. Why the mean? So the arithmetic mean here is generally the common value, the common, the colloquial term for mean is average. So the arithmetic mean is basically the average of all the values. So it basically is denoted by x bar. So for example, a sample mean, so there are two types of mean. So one is a sample mean and population mean. A sample mean is represented by x bar and population mean is represented by mean. So what is x bar then? Let's say I have samples such as x1, x2, x3 and so on xn. These are a set of observations that I have. There are n number of them, right? And I want to find the sample mean for that. The sample mean becomes the sum of all the observations over the total number of observations. So to simplify this, what we can do here is we can write it as sigma xi I equal to 1 to n. So sigma is the common word used for summation. So to simplify this entire summation, we can write it as sigma I equal to 1 to n over n. X bar becomes sigma xi by n. So this is the formula for the sample mean. What changes for the population mean? So whenever you have a finite population mean, the only thing that changes is the number of observations. So here n represents the sample size, uppercase n represents the population size. So n represents capital uppercase n represents the population size. So the arithmetic mean here. So this is the sample birth weight of live-born infants at a private hospital in San Diego, California, during a 1 week period. So you have all the values that you want. So for example, how would you calculate x bar here? So x bar you will have to calculate taking in the observations. So the observations are xi, all of these values. So there are about 20 observations in total. So what do you do now? You calculate the sum. For example, you start from the first value 3265 and then you add 3260. So that you add next value 3245 plus and so on until you add up until the final two values. So the final values 3101 plus 2834 divided by over the value. The total number of observations is 20, so we can write 20. Now, so pause the video right here and take a calculator and try to calculate the arithmetic mean of these observations. So the first thing that you do is calculate the sum of these 20 values. So write it down as the main sum on the top, right, and divide it by the 20 and calculate the value of x bar. So let's talk about the limitations of the arithmetic mean. Arithmetic mean in itself, in general, is a very natural measure of location. So one of its main limitation, however, is one of the values is that it's really oversensitive to extreme values. For example, let's say if you take series of numbers 1, 2, 3, 4, 5, the mean of these numbers is going to be 3. But when you take 1, 2, 3, 4, and in place of 5, let's say we put 10. So you end up with x bar, which is going to be 1 plus 2 plus 3 plus 4 plus 10 divided by 5. So which gives you a value of 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, and 20 by 5, that's 4. So notice that just one change in the number, one number, and the mean went from 3 to 4. So this is the reason why we don't use arithmetic mean very often. So in this instance here, it may not be representative of the location of great majority of the sample points. So this is one of the reasons why we don't use arithmetic mean. Right? So this is one main limitations of arithmetic mean. So let's take another example. So suppose there are 5 physicians who practice in an area. They are surveyed to determine the charges for a certain procedure. So assume that they reported 75, 75, 80, 80, and 280. So the mean for the first 5 physicians would be $118, a value that is not very representative of the set of the data as a whole. The reason is because notice just one value inflated the actual mean really highly. So this single atypical value has an effect of inflating the actual value of the mean. So what are the properties of mean? So the main 3 properties that we talk about, the first one is uniqueness. For a given set of data, there is only one and only one mean. So they cannot have 2 means for the same sets of data. And simplicity, it's easy to calculate. And it's generally affected by extreme values. So the mean, because it's influenced by extreme values, so you can have, therefore extreme values can easily influence the data. So the second measure we're going to talk about is the median. So the common name for this is sample median. So median is basically for a finite set of values, the value divides the set into 2 equal parts. So the median, you have a given set. For example, if you have a set of values, say for example, A, B, C, and D. Mean value is the value that splits the values into two equal halves. For example, C here is the value that splits AB and DA. So C becomes the median. So this is in simple sense. Now let's talk about mean in sense. Mean is generally defined differently depending on the number of observations in the sample. So depending on the sample size, if the sample size is even and if the sample size is odd, we define them differently. So if the samples that are arranged in an odd sample size, they will have a unique central point. So how do you find that central point? Arrange all of them in the order of magnitude, either either in the increasing order or in the decreasing order, and the mid value of the observations represents the median. For example, if you have a sample of size 7, the fourth largest point is the central point in the sense, and that are 3 points smaller than it, and there are 3 points that are larger than it. So the fourth point represents the median. If you have an even sample size, so you will not get a unique central point. So the middle 2 values must be average. So when all the values have been arranged in the order of the magnitude. So for example, let's take a simple example. So let's say I have a set of values 1, 2, 3, 4, 5, and 6. And let's say another set which is 1, 2, 3, 4, and 5. In this set of values, so let's look at the second one first. So in this set of values, we have observations in the order of magnitude, either ascending or descending order. Now, what we are looking for is the mid value that splits the data into 2 equal halves. So if you take 3 here, there are 2 values less than that and there are 2 values greater than that. So 3 here becomes the median. So 3 becomes the median. But if you take the first set of data here, notice that there are 6 values. So because this is even, there is not going to be one single median. So but you will have to average the mid 2 values. So the 2 mid values are 3 and 4 here. So what we'll do here is we'll average the 2 values. You get 3 plus 4 by 2, so 3.5. So 3.5 becomes the median. So this is how we calculate the median. So to make it easier, what we do here is we generally give them simple formulas. So if you have n observations, right? And if the n is odd, so if n is odd, the n plus 1 by 2th observation is the median. So this is when n is odd. If n is even, then it's the average of n by 2th and n by 2 plus 1th observation is the median. So let's take an example of this. So let's see, for the same data that we used above, let's see if it works. So let's see for the same set of data if it works. So let's take another example. Let's say I have 2, 7, 8, 10, 14, 17 and 19. Let's say I have another value set which is 2, 10, 12, 14, 15, 16. So this is the data sets that I'm using. So I've already prearranged them in the order. Now we have to calculate whether n is even or odd. So that's the first rule, right? So let's look at this 1, 2, 3, 4, 5, 6, 7. So n here is 7, so which is odd. So when it is odd, then the n plus 1 by 2th observation is the median. So you have 7 plus 1 by 2. So that is 8 by 2. So 8 by 2 is 4. So the fourth observation is the median. So what is the fourth observation here? So this is 1, 2, 3 and 4. So this is the fourth value. So the fourth value is the median. So the fourth observation here is 10. So that becomes the median. So this was how you calculate the median when you have odd number of samples. Now let's look at the median when you have even number. So you have 1, 2, 3, 4, 5, 6. In this you have n equal to 6, which is even. So even when it is even, it says that it's the n by 2 plus n by 2 plus 1th observation. So there is a total of 6, so which means it's n by 2. N by 2 is 6 by 2, 6 by 2 and 6 by 2 plus 1 average. So what does that mean? It's the average of, so 6 by 2 is 3 and 3 plus 1 is 4. So it's the average of third and fourth observation. So what is the third observation here? So this is 1, 2, 3, 4, 5 and 6. So it's the average of 12 and 14. So when you write it, you're going to get 12 plus 14 by 2. So which gives you a value of 30. So the median here is 30. So here this is the median in this data set, and in this data set 13 is the median. So one way of recognizing whether your median comes from an odd sample or an even sample is if the sample is in the observations, then the sample size is odd. If the sample is not in the observations, then the sample size is even. So if the median value is in the sample, then we say that the total number of observations is odd. If the median value is not in the samples, then it means that the observations are even. So this is the idea behind the mean of a particular amount of data. So now you have the data. So the first thing that you have to do here in this data, arrange the data in either ascending order or descending order. Second, the total number of observations is 20, so which is even. So when you have an even amount of numbers, so you have to have, so this is where you're going to take the average of 20 by 2 and 20 by 2 plus 1 observation. So which means once you arrange them in an order, so you're going to take the average of the 10th and the 11th observation. So which is basically x10 plus x11 by 2. So depending on which one becomes the 10th and 11th observation, provided you arrange them in either ascending or descending order. So make sure to arrange them first and then solve the problem. So try it on your own and see if you can get your answer.
Let's try another problem for median. So here you have a sample of admission white blood counts times 1000 for all patients entering a hospital in Allentown, Pennsylvania on a given day. So you have about 9 observations. So the first thing we want to do is take the observations and start. So the first thing is order. So order the values. So this is the order. Now the total number of observations is 9, so which means it is odd. So the value is n plus 1 by 2th observation, so which is 9 plus 1 by 2th observation, so which is the 5th observation. So the 5th observation here is number 8, so the median is 8, or because it's times 1000 you can write 8000. So what is the strength of the median? So the main strength of the sample median is that it is insensitive to very large values or very small values. Notice that if I change the last value to say 200, there is no change in the actual median of the median value of the problem. The reason is because median does not concern with the extreme values of the either on the lowest side or on the largest side. So in particular, if the second patient, if we had 65,000 rather than 35,000, the sample median would have still been 8,000. So, but the arithmetic mean would increase dramatically from 10,000 to 14,000. So this is the idea here. So the weakness is that the sample median is determined mainly by the middle points, and it is less sensitive because it does not take into account all of the actual numerical values of the remaining data points. So again, try this problem. This is classified based on age, so this is the data. So try this and use this, so try to find out the median for this observation values. So next let's talk about data distributions. So data distributions are basically classified on whether the data is symmetric or asymmetric. If a distribution is symmetric, the left half of its graph will be a mirror image of its right half. When the left half of the graph and the right half of the graph are not mirror images, it's called an asymmetric distribution or asymmetric distribution. If the graph of the distribution is asymmetric, then we call it a skewed distribution. So this is the idea behind skewed distribution. So let's say if you have a data, so let's say if you have data points somewhat like this, say so this is an example of a symmetric distribution. So if you cut the actual graph exactly in half, so if they cut the graph exactly in half, you notice that the left half and the right half are mirror images of each other. So this distribution is a symmetric distribution. So what happens if you have an asymmetric distribution? For example, if you have data that looks somewhat like this, where you have data that's only leaning to one side of the graph, we can call this an asymmetric distribution. So we can call this an asymmetric distribution. Now, the asymmetric distributions are a special case of data distributions. So asymmetric distributions, they are generally of two types. So the first one is a positively skewed distribution. The second is a negatively skewed distribution. So a positively skewed distribution and a negatively skewed distribution depending on the type of graph that looks like. So if you have a graph where if you split the entire point, so in a positively skewed distribution, the points that are above the median tend to be farther from the median in absolute values of the points below the median. For example, let's consider that the median here is somewhere right here. If the points that are above the median, so which means that these are the points, are much farther from the values than the ones that are below the median, we call this an example of a positively skewed distribution. So you have values that are leaning to the left of the graph. So if you have a lot of values leaning to the left of the graph, then we call that a positively skewed distribution. If the values are leaning to the right of the graph, for example, in this distribution here, if you consider this to be the median, if they are leaning to the right of the graph, we call this a negatively skewed distribution. So if they are leaning to the right, we call it negatively skewed. If they are leaning to the left, we call it positively skewed. So the skew comes from the idea that which side is much lower. So which side lower here? So here it is the right side. So we can call this that this is skewed to the right. Now if the same graph is skewed in the smaller values to the left, then we can call it skewed to the left. So if it's less on the left and more on the right, we call it negatively skewed. If it's less on the right and more on the left, we call it positively skewed. So what is the factor that determines the skew of the distribution? So there is a range of values that you can get for skewness. So that is determine the value by skewness. You don't need to remember the actual formula. Just remember that when the skew value is greater than 0, if the skewness value is greater than 0, then there is positive skewness. And if the skewness value is less than 0, then it's negative skewness. And if this value is nearly equal to 0, then it is symmetric. So then it is symmetric. Now let's talk about the relationship between arithmetic mean and the median. In many samples, the relationship between arithmetic mean and the sample median can be used to assess the symmetry of a distribution. For example, if you take a symmetrical distribution, the arithmetic mean is approximately same as, so the mean is nearly the same as the median. But if you have a positively skewed distribution, the mean is greater than the median. If you have a negatively skewed distribution, mean is less than the median. So mean is less than the median. So one way of remembering this is to look at the distribution itself and think about the values there. Median is sort of an example of thinking about a positively charged distribution. Mean in general always comes wherever the values are much larger. So wherever the median generally comes wherever there are more observations. So which means that this would be median, and for example this would be the mean. So this is how the distribution would look like. But the same case when you take median, so median always favors a larger number of distributions. So this would be the median and this would be the mean. So this is how we can determine whether a particular distribution is positively skewed or negatively skewed. So what are the properties of the mean? So what are the common properties that we generally saw are uniqueness, meaning that as with mean, there is only going to be one median for a given set of data, and also the simplicity, because the median is one of the easiest to calculate. And the third one that differs from the mean is that it is generally less affected by extreme values. So it is not drastically affected by extreme values as in the mean. Next, let's talk mode. So mode is the most frequently occurring value among all the observations in a sample. So one way of thinking about mode is, for example, let's say if I have a set of data that looks somewhat like this. So we are looking for the most commonly repeated values. For example, 2 and 2 are repeating twice, 3, 3, 3 are repeating thrice, 4 and 4 is repeating twice. So the most repetitive value is 3, so 3 is the mode. This is the idea behind mode. So this is also one of the most commonly used measure of location. So if all values are different, then there is no mode. But some distributions can have more than one mode. So in fact, one useful method of classifying distributions is by classifying the number of modes that are present. If you have one mode, we call this a unimodal distribution. If it is two modes, bimodal. If it is three modes, and trimodal. So this is how the distribution looks like. So for this data, try and find the mode of that particular data. Again, remember, it's the most repeated value. So we are looking for these values, in these values. So try and find what would be the mode. So pause the video right here and try to solve this problem. So also try to do this problem as well. So see if you can find which one is going to be the most repeated value. So and also try this problem as well. So this is also one other important problem, because this is the problem that you're doing from the start, so that we'll know all mean, median and mode for all of the values. So try this also and see whether you can find the answer. So pause the video right here and try to solve this problem. So what is mode? How can we determine based on mode? What can we say about the distribution? If you have a skewed distribution or a positively skewed distribution, the mean in general is greater than the mode. One way of looking at it is to look at the distributions themselves. So in a distribution, for example, let me draw a symmetrical distribution. In a symmetrical distribution, the peak represents the mode. Right? So the peak represents the mode. So whatever is the peak, the value at the peak represents the mode. So if you take a generally skewed distribution, for example, let's say I have a distribution that's much more skewed, and let's say it's much more, let's say it's skewed this way. Here notice the peak is right here. So this is the mode. But we already said that the mean would come somewhere here. So which means that in a skewed distribution, so this is a negatively skewed distribution. In this negatively skewed distribution, the mode is greater than the mean. Or you can write the mean is less than the mode. Now let's talk about the last type of distribution, which is the positively skewed distribution. So if you have a positively skewed distribution, it looks somewhat like this. In this distribution, the peak is right here. So this is the mode, and the mean comes somewhere in the middle. So this is an example of a positively skewed distribution. So in this distribution, the mean is greater than the mode, or the mode is less than the mean, whichever ones you want to write this way. So one other important factor that we can consider is how would the median come inside this. So let's include the median as well. So we know that in a symmetrical distribution, mode, median and mean, all of them lie at the same point. So in a symmetrical distribution, mean is nearly equal to the median, which is going to be nearly equal to the mode. But in a negatively skewed distribution, the median comes somewhere in the middle between mean and mode. So this would be the median. So in a negatively skewed distribution, mean is less than the median, and then median is going to be less than the mode. This is the case for a negatively skewed distribution. What happens in a positively skewed distribution? So in a positively skewed distribution, the mean is greater than the median, and that's going to be greater than the mode. Again, remember that the x-axis is what represents the value. So these values, so the mean is going to be the largest value. Next comes median, after that comes mode. So mean is the largest value. So in a positively skewed distribution, mean is greater than median and greater than mode. So this is an example of the concept of skewed distribution. So this is how a general symmetric distribution looks like. But when you look at a positively skewed distribution or right skewed distribution, you get mean greater than median greater than mode. But if you have a left skewed distribution or a negatively skewed distribution, you get mean less than median less than mode. So this is how the values will look like. And notice the mean values and the median values based on the skew that the systems have. Now, how to analyze this without having to calculate it by hand? These are some of the famous statistical packages that are used. So the common softwares that are used is what we call R software. This is specifically statistical software. The other one is SPSS. So these are some of the softwares that you're going to end up by using in research, especially if you're going towards medical research. So there you might end up using a lot of these softwares. So it's a good thing to have knowledge of what are the softwares that you can use. So with that, we end measures of central tendency.